Okay, so you were given a couple of practice sheets. We're going to go through the answers, make sure everybody's in good shape with what they need for naming and bonding. Remember, we have to be really solid on covalent because our unit assessment will have both covalent and ionic, so you have to make sure that you're feeling very comfortable with going back and forth between these two different types of bonds. Okay, so let's get started here. They give you an example for hydrogen, and they start you for fluorine. So for fluorine, remember these are our diatomic molecules. This is H2, this is F2. The ones you need to remember, this is called hydrogen. This is called fluorine. Remember, these diatomic molecules don't have any fancy naming. Okay, so let's do the structural model. There's one shared pair between them, so we get one line. So this has a single bond. Now on the next one they say, here's the double bond. They've identified it. Remember, this is the oxygen molecule. This is one of the diatomics you need to memorize. And so it asked us to draw the Lewis dot. So our Lewis dot, we draw the symbol for oxygen, and then we go and we check our periodic table, and we see oxygen is in, oxygen is in group 6A. If you count all the way over, you should have labeled this, but 8, 7, 6, 6, so it has 6 valence electrons. So I'm going to put 6 dots around it. I'll use green. I like green for electrons. So we have one, not that big. The middle dot. So let's do a smaller dot. Sorry, something weird with my, so here we go. 1, 2, 3, 4, 5, 6, and this guy gets 6. 1, 2, 3, 4, 5, 6. Okay, and then in order to determine how many covalent bonds we have, we need to circle our pairs. So these two will get shared, and those two will get shared. And this is where your top line comes from. That's where your bottom line comes from. So this is a double covalent bond. Let's do nitrogen. So start with the Lewis dot structure. We've already done nitrogen a few times, but let's do it again. You go to your periodic table. It's in group 8, 7, 6, 5. Group 5, so it has 5 valence electrons. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We circle the ones that share. This pair will share. This pair will share. And that pair will share. So when we draw our molecular model, one line for each pair. Here's a pair, there's a line. Here's a pair, there's a line. Here's a pair, there's a line. So this is a triple covalent bond. And again, this molecule is one of the diatomic molecules you're supposed to know, called nitrogen. All right, N2, they give you the formulas up here too. All right, so let's do ammonia. Ammonia is nitrogen, but notice it's 3 hydrogens. You see that here, the subscripts, they haven't changed their meaning. The subscript 3 means that I have 3 hydrogen atoms. So that means that I'm going to draw an H, and an H, and an H here. Then you get your periodic table. I've got mine at the bottom, so I don't need to do anything special. Nitrogen, recall, we just did that, had 5. 1, 2, 3, 4, 5. Hydrogen, way over there, we know that has 1 electron, and then we circle the pairs that get shared. Here it goes, here it goes, here it goes. Draw the structural model. So nitrogen, here's a pair right here, so that gets a straight line. Here's a pair right here, so that gets a straight line. Here's a pair right here, so that gets a straight line. So now I have 3 single covalent bonds. See, here's 1, here's 2, here's 3. This is a single bond, this is a single bond, this is a single bond. They are single bonds. Okay, so then the last one on this page is carbon dioxide. So looking at carbon dioxide, so we do carbon, do this here to reinforce that you have 3, right? That's that 3. So we have carbon, and then we'll have 2 oxygen. Let me clear the rest of this stuff off here so it's a little easier to see this one. If you need to go back and look, just pause the video and go back and look. I'm clearing those so we can see this. So I have carbon and oxygen and oxygen. We go back and we look. Carbon, if you look at the bottom of my screen, carbon is in group 4. So it's 4 valence electrons. 1, 2, 3, 4. Oxygen is in group 6. It has 6 valence electrons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we look at what gets shared and we draw a little circle. So here's a shared one. Here's a shared one. Lost track here. Here's a shared one. Here's a shared one. And now let's double check that we haven't messed anything up. We want to be, each of these need 8 to be complete. So let's just check. 1, 2, 3, 4, 5, 6, 7, 8. That oxygen is okay. Let's check carbon. 1, 2, 3, 4, 5, 6, 7, 8. The carbon's okay. Let's check the other oxygen. 1, 2, 3, 4, 5, 6, 7, 8. So we're good. We haven't gone over our octet rule. We haven't done anything crazy. We don't have any kind of charged polyatomic ions or anything. We just have our regular molecule. And so here, between this oxygen and that carbon, we have 2 bonds. And here, I'm sorry, we have 2 shared pairs. So between each of these, so this is a double bond. And this is a double bond. So we have 2 double covalent bonds, okay? All right, now not particularly neat, but you'll be able to do that easier with your pencil. All right, so next page. So next page, we'll keep doing this. So again, how many hydrogen do we need? Pause for a second and figure it out. Look at the subscripts. We need 4, right? So we have carbon. We know that has 4 electrons. Use your periodic table. You should be doing that. It's right down here on the bottom, right here, carbon 4. Hydrogen each has, whoopsie, hydrogen has 1 electron on each hydrogen. Circle your shared pairs. Draw your structural model, carbon in the middle. Here's a shared pair, there's a line. 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 So, is this are these several single covalent bonds or is it a quadruple bond? Well, let's look. Between the carbon and the hydrogen, I only have 1 shared pair, so this is a single bond. 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 So we have 4 single covalent bonds in this particular example. Now water, you should be able to do this one really easily. So I'm going to skip the Lewis dot for this because I'm just going to skip the Lewis dot and the structural for this because this is actually in the class notes. You should know by now that water looks like this, and so it has 2 single bonds. And we also know that while dihydrogen monoxide is technically how we would name this, that yeah, scientists don't call it that. They call it water. Okay. Practice naming. If you want to go back and practice naming for methane, this is carbon tetrahydride, right? If you want to go back and practice naming on the other ones, let's go back there for a second. So hydrogen, fluorine, oxygen, nitrogen. This one, ammonia, is really nitrogen trihydride. You know this one, you guys know this one, carbon dioxide, right? Okay. So it's a good idea. Anytime you get these at this point, as we're getting close to assessments, practicing all aspects of this, how the teacher could ask you, is always a great way of doing things. Okay, so let's look at sulfur dioxide, right? Sulfur dioxide. So remember that mono is only used if the second one is 1, not if the first one is 1. Has 1 atom. So sulfur is in group 6. So sulfur is going to have 6 electrons. 2, 3, 4, 6. And then oxygen, we know, is in group 6. So it's going to have 6 electrons. So I'm going to put an oxygen over here and an oxygen over here. 2 oxygens, right? 6 electrons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then we circle our pairs. Well, let's see. This one. Did I do this right? This one. And this one. I think this is the one I should have told you to skip. This one you skip. One pair of must be split up for this one to work. So we're going to skip this one. This one's not a basic model. My apologies. We skipped the boron one too because boron is a metalloid, and so some of these worksheets are pulled from more advanced sources, and so it is what it is. So let's go through and practice bonding and naming these things. So let's start with this one. So ionic, right? Metal, non-metal. You should be checking your periodic table when you do this. Metal and non-metal. So it's calcium chloride. It's an ionic bond. Non-metal and non-metal. Carbon dioxide, covalent. Non-metal and non-metal. Water. Dihydrogen monoxide, covalent. All right, this one, look at this one I don't have. Some of these we've done so many times we've got to memorize, but I certainly don't have SR memorized, and you probably don't here. Here it is right here, SR strontium. It's right here on your periodic table, and that guy should look very familiar. That's a polyatomic ion, right? And so you should have that chart in your notes. So that's a metal. This is a polyatomic ion. That makes it an ionic bond. And you'd want to look this up. It's phosphate. You look it up in your periodic table. Sorry, your polyatomic chart, the name. So strontium phosphate. All right, K2O4. Well, let's go again. Here's another one we don't use as frequently, so we definitely want to look it up. Potassium's over here. Oxygen's over here. Metal, non-metal. Ionic bond. Potassium oxide. All right, let's practice good habits, right? So here's sodium, here's fluorine, metal, non-metal, ionic bond. Oh, sorry, this one is wrong. All right, I said it right, but I've written it wrong. So let me type over this one so you guys don't get confused. This was ionic, right? See, we can make mistakes so easily. So this one's ionic, metal, potassium, oxygen, non-metal, my apologies. Then 6, sodium, sodium, metal, fluorine, non-metal, ionic bond. Good, we're back on track now. All right, so aluminum. Now aluminum's in a weird spot. We've got to watch to make sure we're clear on where our metalloids are, boron, silicon, germanium. So aluminum is definitely a metal. Carbonate, CO3 is in one of those polyatomics again. So this is an ionic bond. Aluminum carbonate, CH4. We've practiced this one. This is methane, right? C is here, non-metal. H is there, non-metal, even though it's on the other side. And so this is carbon tetrahydride, and it is covalent. Let's look at sulfur. Here, number 9. If you're going too fast, just pause it in between. Sulfur is a nonmetal. Oxygen is a nonmetal. Covalent bond. Sulfur trioxide. Number 10, lithium metal. Bromine over here, non-metal. Covalent bond. Sorry, covalent. What is that? Come on. We didn't do covalent for that. Metal and non-metal. Fix it. Ionic. That's right. Gotta watch me. So lithium bromide, right? Metal, non-metal, lithium bromide. All right, so here we go. Magnesium, way over here. Magnesium, and then another polyatomic phosphate, right? And so that's ionic. Magnesium phosphate, ionic. Okay. Now, this one we haven't played with a lot, but if you look at your polyatomics, which you should, as soon as I see this HPO4, I'm headed for my polyatomic ions, and I believe that's hydrogen phosphate if I remember correctly. My chart's not right next to me. And this guy is also on your polyatomic chart. It's ammonium, and this takes the place of a metal ion. So this is actually ionic. It is not one we will test over, but it is ionic, and you should always check that polyatomic chart. You don't see CO2 or CO on those, so you'll know those aren't. Okay, here's your sugar molecule, right? Carbon, hydrogen, oxygen, all nonmetals, covalent bond. Water molecule, we know that that's covalent, so we're in good shape. Okay, and then last one, again, this is another covalent compound. Carbon, hydrogen, oxygen. Okay, so I'm not going to, I think if you, sorry. So this says list each compound and how many are in each compound, how many atoms are in each compound. And you should remember that this is just a review of doing the subscripts for each one. And when we have subscripts out here, we sort of distribute it in. So I'm going to go through this pretty quickly. So number 2, 1 carbon, 2 oxygen. Number 3, 2 hydrogen, 1 oxygen. Number 4, 3 strontium, 2 phosphorus, you've got to put that thing in there, and then 2 times 4, we have 8 oxygen. 5, 2 potassium, 1 oxygen. Number 6, 1 sodium, 1 fluoride, fluorine, that's an easy one. 7, 2 aluminum, remember distribute this outside one into the polyatomic, so 3 carbon and 9 oxygen. 8, 1 carbon, 4 hydrogen, 9, 1 sulfur, and 3 oxygen. 10, 1 lithium, 1 bromine, again easy. Number 11, 3 magnesium, 2 phosphorus, 8 oxygen. This one gets even crazier, but don't get confused. Take it slow. Here are parentheses. We take that subscript, we distribute it in, so we have 2 nitrogen, 8 hydrogen here. I have an error in the key. 8 hydrogen plus 1 here is 9 hydrogen on this 12. 9 hydrogen. 1 phosphorus and 4 oxygen. Okay, so make sure you add the elements that are the same. They aren't, just because they're in different spots in the chemical formula, don't mean they're different. We had this when we had chemical equations and we were taking that test. We put it in all different places and made sure you were checking everything. So doing the list is helpful. Okay. All right. So then on 13 you have 12 carbon, 22 hydrogen, 11 oxygen. Water, totally easy one for you guys. 2 hydrogen, 1 oxygen. 15 is not for here for some reason, but let's add it. So we have carbon, 2 carbon. We have, whoopsie. We have hydrogen. My apologies, working late tonight. So hydrogen, we have 5 here and 1 there, that makes a total of 6, and then you have oxygen, just 1. So good idea to pause here and take a look, make sure everything makes sense. You should be able to go back and forth between ionic and covalent. You should be able to name. The quiz will be primarily naming covalent compounds, but ionic compounds, you should be able to name that. Make sure you know the conventions, that the first element, regardless of ionic or covalent, that the first element sort of keeps its name for the most part. Covalent gets a prefix added unless it's just one atom in the first element. And then the second element always gets that IDE thing to it. Okay. All right, so here's some more practice, and we've done a lot of these, so I'm not going to go back through them. But if you look in your notes, I've given you the diatomic molecules for all of these. You should be able to identify the covalent bonds. Hydrogen is hydrogen. Let me just do the structural models. So hydrogen has one shared pair of electrons, so it has a single covalent bond. Oxygen has two shared pairs, so it has a double bond. Nitrogen has three shared pairs, so it has a triple bond. Fluorine, and one of the easy ways to look at this, and we did fluorine already, I think. So fluorine is over here in group 7. So each of them are going to want one more, so they can just share one pair. So it's a single covalent bond. So fluorine, chlorine, bromine, iodine, look at that. They all have single bonds in the diatomic molecule. Oxygen, sulfur, they all have double bonds, just like this one here. They're in group 6. Each one's going to want 2, so they're going to have to share 2 pairs. Nitrogen and phosphorus are in group 5. They each want 3, so these are all going to have triple bonds when they're in their diatomic molecule. And carbon is the only non-metal in that 4th row, and it has quadruple bond. But remember, these are really like rare. Okay. All right. Next. We've done this one. We've done this one. I don't remember if we did this one. So let's do it again, just to make sure we're drawing our structural model. So sulfur has 6. Hydrogen has 1, so we're going to form single bonds in between this. Sulfur is going to want to share a pair with this hydrogen and share a pair with this hydrogen, and so that's the molecular. It has single bonds. Nitrogen trihydride, we already did this one. There's a lot of repetition in some of these practice sheets to get you to do that. Carbon monoxide, we're going to skip. Carbon dioxide, you already know, has 2 double bonds. And nitrogen trichloride, we'll do nitrogen trichloride, that's fine. So nitrogen trichloride, here's the naming thing too, in case you forgot and go back to your notes. So nitrogen trichloride, we have 3 chlorines. Each chlorine, it's in group 7, each chlorine only wants 1. Nitrogen's in group 5, so it wants access to 3. So if this guy has access to 1 of nitrogen's electrons, and this guy has access to 1 of nitrogen's electrons, and this guy has access to 1 of nitrogen's electrons, then all the chlorines will be happy, and because I have 3 chlorines, then the nitrogen's happy. All right, sulfur trioxide. Sulfur trioxide is a skip one for you. We're not going to do that one either. Okay. All right. So for each of the covalent compounds, we're going to provide the name. So here's our name. You should be able to start feeling like you can do this really easy. Sulfur dioxide. Got a oxygen has a subscript of 2, so number 2, nitrogen trioxide. Remember that first one, if I have only 1 atom of that first compound, I do not get mono. Only prefixes when I have more than 1. So here I have 2 phosphorus, so it's diphosphorus. Pentoxide. Remember, we watched those double valve things. And this is iodine pentafluoride. Okay? So it says now do the chemical formula. Well, the chemical formula for covalent bonding is so easy because The prefixes tell us what subscripts or no subscripts we have. So this tells us I have one atom of sulfur, and monoxide tells me one atom of oxygen, and we know that we never put subscripts of 1. That's ridiculous. It's there. We know it's there. We don't need a 1. So we never do this. S1O1. No way. We're scientists. That's crazy. All right. So nitrogen. Dinitrogen. So we get a subscript of 2. Pentoxide. So we get a subscript of 5 here. Real important for you to know your prefixes. Tetraphosphorus. So phosphorus is there. Tetra is the prefix for 4. Trisulfide. Sulfur is there. Subscripts of 3. Sulfur hexafluoride. So sulfur by itself, and then fluoride, hexafluoride 6. Yeah, let's double check. Let's double check. Make sure I'm right, because it's easy to confuse hexa and hepta, right? They're really close together, hexa and hepta, but there they are. Hexa is 6, hepta is 7, okay? So you got to memorize those, and whatever trick you want to use to do that. All right, so here we go, practice. Now this one makes it kind of easy because they kind of go back and forth. Let's go down and just name the ones that aren't named. So here we go, phosphorus. That is a, I think on your sheet it's easier to read. Phosphorus trifluoride. My apologies while I pulled one of the original sheets. When I copied it, it didn't come off very well. It's a 5. So phosphorus pentafluoride. That's that first one. The number 3 is dinitrogen pentoxide. Gotta watch those double vowels, right? Here we had pentafluoride, but we only have pentoxide, so I have to really be careful of that. And then I have tetraphosphorus. Decoxide. Yeah, it's bizarre, isn't it? Okay, and then here we have chlorine, beginning, right? Chlorine dioxide. And then we have oxygen difluoride. Now, look at this. If you guys look at this, when we go back to, doing things, where's xenon? Look at that. Xenon is in the noble gases. And we have said, no, 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 never, 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 never. So we aren't going to do that. The fact of the matter is, yeah, sometimes it does, but you can wait until you get to a full-fledged chemistry class, full-year chemistry class to deal with that. We are not going to deal with it. I want you guys to remember they are non-reactive, because it's not really frequently that they start bonding with stuff. So let's go to 2, carbon tetrafluoride. So carbon, there's only 1 of them. Chlorine, there are 5 of them. And I'm sorry, 4 of them. I said it right. I said it wrong and wrote it right. So that goes as a subscript, right? Then nitrogen gets 1. Heptaiodide, I for iodine. And hept is 7. Yeah, remember? 7, hepta. Yeah, you got to be careful of that. Here it is, right there. Hepta. And so you guys can go through this a lot more slowly. You can check you should be checking your periodic table. You should be checking your charts until you get it all memorized. I'm just trying to go through quickly to give you those answers so you can study with them. So dinitrogen, so N with a subscript of 2, trioxide, O with a subscript of 3. And then nitrogen dioxide. Nitrogen, no subscript. Oxygen with a subscript of 2. Okay, so we should have gone back and forth enough to give you a solid sort of overview. If you have questions, you can email me. and through Edline, and that's it. Have a great one. Thanks.